So hello everyone. So welcome to this new video. So in this video I'm going to explain in brief about the process of Nyquist plot, how to get the Nyquist plot. Okay. So here in this session I'm going to solve two important problems which are there in the model question paper only. Okay. And in this one full session I'm going to explain in brief about Nyquist plot. Okay. Yeah. So for Nyquist plot what we should be doing is they would be giving you one simple transfer function. Also we should be trying to find the stability, and how to find the stability also I'm going to tell you all. Okay, so the main thing of Nyquist plot is divided into three plots. Okay, we should be drawing three plots in order to get the Nyquist plot. One is polar plot, one is inverse polar plot, and the third important part is this curve here. You can see from this point to this point we are getting one curve, right? That curve is named as, listen to the name carefully, the name that is given is Nyquist contour. Okay, Nyquist contour. This from this point to this point, this curve here, where we are having the infinite radius, and this since why this is infinite radius, because this line is there, right? It is in this axis. From this here it is infinite, so that's why this line is going to infinite. So that's why in order to representation we have stopped this point yet, but in general this is not stopping. So that's why this radius here which we get is infinite in nature. Okay, and that is called as Nyquist contour. Okay, please see the pronunciation, Nyquist contour. Okay, so these three things we should be keeping in mind when we do the Nyquist plot analysis. Okay, so now let's try to plot the Nyquist plot. First we should be drawing this section of Nyquist contour here. This section is divided into four parts. Okay, that is, this first line is there, right, from here to here. Okay, this is the first part. Okay, and this whole curve till here, this is the second part, and see the direction here. Okay, this is the second part of the plot, and here this is the third part. This from this line to this line, right, this is the third part of the plot, and from this point up to this small circle is there, right, it is the fourth part of the plot. Okay, where the outer radius of this Nyquist contour is given infinite in nature, so that's why it is represented as capital letter R e power j theta, where R tends to infinity. And similarly this small circle is there, right? So here the value of radius is tending to 0, because this, in order to do the representation purpose, it is visible, but in practically this is not even visible to our naked eye. Okay, so that's why here this is the circle of 0 radius, and it is represented as small letter R e power j theta, and here the graph is of sigma versus j omega. Okay, so now first thing what we will be doing is, first step is S is equal to j omega, that is, you should be doing one polar plot. We should be plotting polar plot. Okay, that polar plot section I'm in different section only I have explained it. Okay, let's get to the second curve now. So this curve, right, this line is for polar plot, and this Nyquist contour is for this second part. That is, what we should be doing is, we should be substituting the value of S is equal to limit capital R tending to infinity R e power j theta, where the theta ranges from 90 degree to minus 90 degree. As you can see that it starts from here, this is the 90 degree, up to, so from here to here it is 90 degree, and from here to here it is minus 90 degree, right? So that's why we can say that this is from 90 degree to minus 90 degree. So now what we should be doing is substitute this value of limit in this g of s question, whatever is given, that is g of s limit R tending to infinity. In place of s, now wherever s is there, you should be substituting as R e power j theta. That's it. That much only you should be doing. Where in place of s you should be substituting R e power j theta and apply the limits. Okay, so limit R tending to infinity, 1 plus, in place of s it is R e power j theta, so 1 plus 4 R e power j theta divided by s square, so R square e power 2 j theta into 1 plus s, so that's why 1 plus R e power j theta into 1 plus 2s, that is 1 plus 2 R e power j theta, the limit R tending to infinity. Then again in this term take 4 R e power j theta common outside, then again in the bracket what you would be left with 1 plus 1 divided by 4r e power j theta divided by, in the denominator side take r e power j theta as well as 2r e power j theta common outside, so that here when we take these two outside we would be left outside it is 2r power 4 e to the power 4 j theta. Since we have here 2 j theta and j theta, it would be 4 j theta divided by, this would be now 1 plus 1 divided by r e power j theta, 1 plus 1 divided by 2 r e power j theta. Then here again limit r tending to infinity, so we can cancel some of the terms here. 2 ones are 2 twos are, 1 r would be getting cancelled, and 1 j theta and 1 power of j theta would be getting cancelled. We would be left with limit r tending to infinity 2 divided by r cube e power 3 j theta into these other terms, write it as it is. Then g of s is equal to limit r tends to infinity. Now apply the limits only for this term. Okay, apply the limits for this term, that is 1 plus 1 divided by 4 r e power j theta, that is r, in place of r substitute infinity, so this whole term here we will be getting it as infinity, and we know that 1 by infinity is 0, so 1 plus 0 is equal to 1. Same thing here. So if this r is infinity, this whole term is infinity, so 1 by infinity is 0, 1 plus 0 is 1. Again this is infinity, so 1 by infinity is 0, 1 plus 0 is 1, so this whole term would be equal to 1 right now. So we would be getting only this term now, that is limit r tending to infinity. So keep this limit as it is because we have not applied the limit for this r cube, so that's why 2 by r cube, and here this e power 3 j theta I have shifted it to the numerator side, so we would be getting e power minus 3 j theta. Okay, so now in this equation what we can conclude, that magnitude is equal to 0. How magnitude, this is the magnitude side and this is the phase side. Okay, how magnitude is equal to 0 when we apply the limit r tending to infinity, so this would be 2 by infinity. We know that any number divided by infinity is 0, so that's why we would be getting magnitude as 0. And also phase ranges from minus 270 degree to plus 270 degree. How means, initially we have taken the range of theta for this condition is minus 90 to minus 90 degree, multiply this 90 with minus 3 here, so 90 into minus 3 is minus 270 degree, and minus 90 into minus 3 is plus 270 degree. So like that's why we are getting the range from minus 270 to 270, that is 1.5 circle. Okay, we know that total angle of minus 270 degree to 270 degree is total angle made by it is 540 degree, and we know that one full circle makes an angle of 360 degree, and one half circle makes an angle of 180 degree. If we add these two, we would be getting 540 degrees, so that's why we would be completing 1.5 circle anti-clockwise, because it is moving from minus 270 degree to plus 270 degree, so that's why the direction is anti-clockwise. Okay, since in this plot here we can see that from here it is 0 degree to 90 degree. Okay, this is 180 degree clockwise, this is 270 degree, and this is again 360 degree. But in anti-clockwise, how we should be taking is, yeah. So now third thing is s is equal to minus j omega inverse polar plot. Okay, this is not required because when we do one calculation for polar plot, it's not required to do the inverse polar plot because it is the mirror image of the polar plot whatever we draw. So the fourth step is the small curve here, small circle here. For that we should be trying to same thing again, s is equal to limit small r tending to 0, small r e power j theta, where theta ranges from minus 90 to plus 90 now. So you can see that it ranges from minus 90 degree to plus 90 degree. Okay, so this is minus 90 degree. Okay, so from here it ranges from minus 90, it goes to plus 90, so that's why minus 90 to plus 90. Okay, then again g of s is equal to, in place of s substitute small r e power j theta. Okay, again the same thing here, we should not taking this common because we are applying our limit r tending to 0 directly here, because if we apply directly here, what we would be getting, we should be getting this we should be substituting the limits in such a way that the bracket terms are there, right, that should be equal to 1. Okay, so in such a way you should be substituting the limit. So here if we substitute the limits directly here, it has 4 into 0 e power j theta, what we would be getting, this whole term would be 0, and again if we substitute here 0 0, so this whole term would be 0, again we would be left with 1 plus 0 is equal to 1, and 1 by r square e to the power 2 j theta would be remaining. Okay, this limit you should be keeping as it is because we have not applied limit for this r square, so let's say 1 by r square, and if you bring this e power 2 j theta to the numerator side, we would be getting e power minus 2 j theta. Now apply the limits. 1 by r tending to 0, so 1 by 0, anything divided by 0 is infinity, so this is the magnitude side, this is the phase side, so that's why this magnitude we will be getting it as infinity, and phase ranges from 180 degree to minus 180 degree. Okay, since multiply 90 degree to minus 2, that is minus 90 into minus 2 is plus 180, and 90 into minus 2 is minus 180. So our phase ranges from 180 degree to minus 180 degree, one full circle. Okay, we know that 180 to minus 180 we would be getting one full circle clockwise. Okay, since it is starting from plus 180 to minus 180, it would be rotating clockwise direction. Okay, so these two things you should be keeping in mind while we draw the Nyquist plot, because this would be coming in the picture afterwards. Okay, so now for polar plot, these are the calculations to be done. That is, you should be substituting s is equal to j omega. That is, in place of s, substitute j omega. So g of j omega, write the term, substitute in place of s, write j omega and write this term. Then write standard form. Standard form of g of j omega is represented as magnitude of j omega into the phase of g of j omega. Now the magnitude of g omega is given as square root of coefficients, that is 1 square plus imaginary term square, that is 4 omega square, that is 4 omega the whole square, that is 16 omega square. That is, you should be taking the coefficient square. Okay, so this is 1 square plus 4 omega whole square divided by, again since its coefficient is omega square. Okay, then square root of again 1 square and omega square into square root of 1 square and 2 omega whole square, that is 4 omega square. Name it as equation 1. Similarly, phase of j omega is given as, since you can see that this is in the denominator side, so plus tan inverse of 4 omega. Okay, that is imaginary part divided by real part. That is, imaginary part is 4 omega divided by real part is 1, so we are getting tan inverse of 4 omega minus 180 degree, again in the, since it is in the denominator side, so this is its coefficient of imaginary part is omega square. Since we know that omega, tan inverse of omega is omega by the real part is 0, so omega by tan inverse of omega by 0 is minus 90 degree. Since we have omega square, we would be getting the angle as minus 180 degree. Okay, similarly this is tan inverse of imaginary by real, that is omega by 1 omega minus tan inverse of 2 omega by 1, that is 2 omega. Okay, name this equation as equation 2. Then now what we should be doing is, we should be finding the values of omega is at omega is equal to 0 and at omega is equal to infinity. These two are called as essential points. Okay, at omega is equal to 0, magnitude is equal to infinity. Okay, if we substitute the value of omega in this magnitude equation, if you substitute the value of omega as 0, we know that 1 divided by 0 is infinity, so magnitude we will be getting it as infinity. And also at omega is equal to 0, the phase we are getting it as minus 180 degree, because we know that when we substitute the value of omega is equal to 0, 0, 0, these three terms also would be equal to 0. We would be left with only one angle, that is minus 180 degree. The phase is minus 180 degree. And also at omega is equal to infinity, the magnitude we would be getting it as 1 divided by infinity square, that is infinity only. We know that 1 by infinity in general is 0, so magnitude we would be getting it as 0. Also phase we would be getting it as tan inverse of infinity. Now again plus tan inverse of infinity, so plus 90 minus 180 minus tan inverse of infinity, then minus 90 minus tan inverse of 2 infinity, that is again minus tan inverse of infinity only, minus 90. If we sum it up, we would be getting the phase angle as minus 270 degree. So this data we would be keeping as it is. So now what we should be doing is, for this polar plot equation, we should be trying to separate the real part as well as imaginary part. So that's why separate real and imaginary part. G of j omega is equal to 1 plus 4j omega divided by j omega square, 1 plus j omega, 1 plus 2j omega. What now we should be doing is, we should be multiplying the complex conjugate of these two denominator terms. Okay, that is 1 plus j omega, 1 plus 2j omega. Now we should be multiplying the numerator and denominator by complex conjugate term, that is 1 minus j omega and 1 minus 2j omega. Divide it, then simplify it by multiplying. Okay, that is, if we see here in the j omega square, if we substitute this, would be j square omega square, and we know that j square is equal to minus 1, so that's why I have written only omega square here, and minus I have written in the numerator, so that's why numerator 1 plus 4j omega into, so simplify this, 1 into 1 is 1 minus 2 omega square, so minus 2, that's later part, 1 into 1 is 1, then 1 into minus 2j omega is minus 2j omega, minus j omega into 1 is minus j omega, and minus j omega into minus 2j omega, we would be getting it as minus 2 omega square. Then in the denominator part, omega square and 1 plus 2j omega, 1 plus j omega and 1 minus j omega, it is of the form a plus b, a minus b, you would be getting it as 1 plus omega square if you substitute it. Again, this is 1 plus 2j omega and 1 minus 2j omega, it is a plus b, a minus b. Again, we would be getting 1 plus 4 omega square. Okay. Now again simplify this. Okay. So here simplify and write it. These and all simplification steps. Simple max, you can refer it. Okay. Simplify here. So now after simplifying, what we should be doing is the real, in this numerator part, the real terms separated, divided by the denominator, write it as it is, plus write j here and write all the imaginary terms. What and all are the imaginary terms? This is 3j omega, 4j omega. It 3j omega minus 4j omega, it is minus j omega. So here I have taken j common and written as minus omega. And here we have 8j omega cube. Again, j I have taken it outside and written it as 8 omega cube divided by this numerator only. Okay. So like this we have separated real part as well as imaginary part. Okay. I have written it here, real part, imaginary part. Okay. Then for intersection to imaginary axis, what we should be doing is the real part of j omega, we should be equating it to 0. Okay, so this real part here I am equating it to 0. If we, this whole numerator part would be becoming 0, because if we cross multiply it is 0. So minus 10 omega square minus 1 equal to 0. Minus 10 omega square is equal to plus 1. Omega square is equal to minus 1 by 10. So omega is equal to plus or minus j. Since this we have minus, if we take square root of minus term, we would be getting one complex term j, square root of 1 by 10. But the value of frequency cannot be imaginary in nature, so that's why not possible, because frequency cannot be imaginary. So this condition will not satisfy. In the Nyquist plot we won't get any intersection to imaginary axis. Similarly, for intersection to real axis, what we should be doing is the imaginary part of j omega, we should be equating it to 0. That is, this is the imaginary part of j omega. This is the imaginary part that we should be equating it to 0. Again, this denominator would be cross multiplied, it would be becoming 0. So 8 omega square minus 1 equal to 0. 8 omega square equal to 1. Omega square is equal to 1 by 8. So omega is equal to plus or minus square root of 1 by 8. But in this case, you should be taking the positive value. So omega is equal to plus square root of 1 by root 8. Okay, so this is the valid frequency. Okay, so now what we should be doing is this frequency here we should be substituting in the omega, is put omega in equation 1 and equation 2, which in general we have taken for magnitude of j omega and phase of j omega. In place of omega, substitute the value as 1 by root 8. Okay, rewrite this equation in the calculator. Substitute the value of omega as 1 by root 8 for both magnitude as well as phase. If we substitute it, this is the simplified answer we are getting. Magnitude of j omega, we would be getting it as 10.66. Phase of j omega, if we would be getting it as minus 180 degree. Okay, so now using these data, we should be drawing this Nyquist plot now. Okay, so now how to draw this Nyquist plot, just listen carefully. First, what we should be doing is, we should be first step, what is the first step here? We should be drawing the polar plot. Okay, so how to draw the polar plot is, we should be checking the data for polar plot. What is the condition for polar plot? What are all the data we are assumed? That is, at omega is equal to 0, magnitude is infinity, and phi is, the phase is minus 180 degree. That is magnitude, this is magnitude area sigma. Okay, and phase j omega, phase is minus 180 degree, so it would be coming somewhere here. Okay, and start this plot from here, and here we are getting one intersection point at real axis. Okay, that is around somewhere here we will be getting it as 10.66. okay, draw one curve like this. Okay, intersect to 10.66, and here it would be coming at an angle of 270 degree, because at omega is equal to infinity, we would be getting magnitude is equal to 0 and phi is equal to minus 270 degrees. So that's why magnitude is 0, it would be magnitude is 0 here, and phi is angle 270 degree here. So that's why from here we would be getting, and it would be getting joined here. Okay, so this is the curve of polar plot, this whole curve. And also inverse polar plot is the mirror image. This is the inverse polar plot. Okay, so that's why step number 1 and step number 3 is done. So now we will be getting to step number 2, that is Nyquist contour. So here check this condition now. Magnitude is equal to 0, phase is equal to minus 270 to plus 270 degree. That is magnitude is equal to 0, and from this 0 point we should be drawing small circles. Okay, but in order to represent in the Nyquist plot, we are drawing some big circles like this. In general, the circles are very small because the radius magnitude is 0. Since it is 0 radius, we should be drawing 1.5 circles, that is from this point, from minus 270 degree you should start drawing the circle like this, from minus 270 degree. Okay, this is one circle here, this much is one circle. Okay, then from this point to this point you would be drawing 1.5 circle anti-clockwise direction. Okay, this is the anti-clockwise direction. Okay, in this way we should be drawing the anti-clockwise circle. Okay, so this is the third part, that is to draw the Nyquist contour. Okay, using this. And now the fourth part, that is the outer circle, that is r tending to 0. Here magnitude is infinity and phase lies from plus 180 to minus 180 degree. So here magnitude is infinite here. Okay, and from here, this is the point you should not be drawing from here, from where we have taken the inverse polar plot, minus 180 degree to plus 180 degree, that is one complete circle. Also this should be drawn in clockwise direction. So that's why from minus 180 to 180, the outer circle at magnitude is equal to infinity, and omega is equal to infinity, we will be drawing this outer circle, and like this the simple Nyquist plot is plotted. Also they have told to check the stability of this Nyquist plot. Okay, in order to find stability there are few steps, that is there is one formula to find the stability, that is n is equal to p minus z. Now what is this n here? This n stands for encirclement. Okay, so whatever the Nyquist plot we get, we should be checking for how many circles we are got, means not the shape of circles, that is encirclement means one plot like this you should be checking, it should be going in the same direction. See, for example, this plot is there at this one circle here, this is one encirclement here. Okay, and this is the outer circle is the other encirclement. Okay, it is moving in a circular direction. Okay, these two are the encirclements. Both encirclements are moving in clockwise direction, as you can see. So that's why we can say that whenever the encirclements are moving in clockwise direction, it should be always represented in the negative values. Whenever the encirclements are moving in the anti-clockwise direction, it should be always represented in the positive values. For example, in this case the value of n is equal to minus 2, because we are having two encirclements, both are in the clockwise directions, that's why n is equal to minus 2. And this p stands for number of poles in the number of open loop poles in the right hand plane. Okay, number of open loop poles in the right hand plane, and also this z stands for number of closed loop poles in the right hand plane. These are not poles and zeros, both are also poles only. It is represented by one is for open loop and one is for closed loop. Okay, p and z. So here, since no pole is on the right hand plane, because if we check this p, even if we check the equation here, see, we know that poles are always lie in the denominator side of the transfer function. If we check here, two poles are at 0, one pole is at s plus 1 is equal to 0, so s is equal to minus 1, and one pole is at 2s plus 1 is equal to 0, so we would be getting s is equal to 0.5 minus 0.5. Okay, all the poles values are either 0 or negative, so we can say that no pole are on the right hand plane, all of them are on the second quadrant, or all poles are negative are on the left hand plane. So we can say that since no poles are on the right hand plane, and this p stands for number of closed loop open loop poles in right hand plane, since we don't have any poles in right hand plane, so that's why we can conclude that p is equal to 0. Also, if we substitute the value of p and n in this equation, now what we would be getting, n is minus 2 is equal to 0 minus z. So if we solve this, we would be getting z is equal to 2, that is the number of, so there are two poles in closed loop system on RHP. So whenever we have the positive two poles, whenever we get the value of z here as positive, we can directly say that the system is unstable, since we have got two poles in closed loop system in right hand plane. Okay, whenever we get any poles in the right hand plane, in general we say that the system is unstable, right? So that's why here in this case the two poles we have got in right hand plane, so directly we can conclude that the system is unstable in this case. Okay, so in this way we should be drawing the Nyquist plot. Hope you understood this problem. Okay, let's discuss one more simple problem. So here this is the second simple problem, that is construct a Nyquist plot for a unity feedback system whose g of s is given as phi divided by s into 1 minus s. Okay, so again the same thing, draw one graph of sigma and j omega, sigma versus j omega. Draw the plot for Nyquist contour, which I've already explained. Okay, the first part is for polar plot, the second part is for Nyquist contour, the third part is for inverse polar plot, and this is the small circle where the radius is tending to 0, and this larger circle radius is tending to infinity. It is represented as r e power j theta, capital R e power j theta, and here it is represented as small letter r e power j theta. Again, in the first step, this first line is for polar plot, the second curve is for what we should be doing is s is equal to limit r tending to infinity r e power j theta, where theta ranges from 90 to minus 90, as we have discussed in previous problem. In place of s, substitute it as r e power j theta, that is g of s is equal to limit r tending to infinity 5 divided by r e power j theta into 1 minus r e power j theta. G of s is equal to limit r tending to infinity 5 divided by, so here in this term take r e power j theta common outside, so we would be getting here as r square e power 2 j theta into 1 minus 1 by r e power j theta, and therefore g of s is equal to limit r tending to infinity 5 by r square. So for this bracket term, apply the limit, that is in place of r, substitute it as infinity. So we know that, so r substitute it as infinity, so we know that anything divided by infinity is 0, so 1 minus 0 is 1, so this would be converted, this would be equal to 1 now, so we would be left with 5 by r square into e power plus 2j theta. If you bring it to the numerator, it would be e power minus 2j theta. So this is the magnitude side, this is the phase side, and for this magnitude side, if you apply the limits r tending to infinity, so 5 by infinity would be 0, that's why our magnitude would be, we would be getting it as 0. Similarly, the phase side, e power minus 2j theta, multiply 90 into minus 2, we would be getting minus 180, minus 90 into minus 2, we would be getting plus 180. So therefore our phase would be ranging from minus 180 to plus 180. We can say that minus 180 to plus 180, it will be doing one complete circle in anti-clockwise direction, since it is going from minus 180 to plus 180, that's why the direction is anti-clockwise. Similarly, for the fourth step, third step is inverse polar plot. Fourth step, s is equal to limit r, small letter r tending to 0 now, small letter r e power j theta, where the theta varies from minus 90 to plus 90 now. G of s is equal to limit r tending to 0, 5 divided by r e power j theta into 1 minus r e power j theta. Directly apply the limits here, that is limit r tending to 0, 5 by r, don't apply the limits for this, apply only for bracket term, that is this is 0, so 1 minus 0 is 1, we would be left with 5 by r into e power j theta. If you bring it to the numerator side, it would be e power minus j theta. So here this is the magnitude side, this is the phase side. If you apply limits for this magnitude side, 5 by is 0, anything divided by 0 is infinity, so that's why you would be getting magnitude as infinity. Phase you would be getting it as minus 90 into minus 1, it is plus 90, 90 into minus 1, it is minus 90. Okay, so that's why we would be getting minus 90 to plus 90, it is total of 180 degree, and we know that 180 degree is half circle, so it is moving from plus 90 to minus 90, so that's why it is moving in the clockwise direction. Okay, so now for polar plot again, replace s is equal to j omega, so g of j omega is equal to 5 divided by j omega into 1 minus j omega. Write it in standard form, g of j omega is equal to magnitude of g of j omega into the phase of g of j omega. Magnitude of g omega is represented as square root of the coefficient, that is square root of 25, or else you can keep this square this as it is, as 5 only. If you don't do the change, it's one and the same. Then phase of g omega, that is tan in the numerator side, so plus tan inverse of 0, since we don't have any imaginary term, so 0 divided by real term is 25, 0 by 25 is 0, minus in the denominator side we have omega, so that's why you will be getting minus 90 degree, minus tan inverse of minus omega. So angle g of j omega is minus 90, so this is 0, minus 90 minus tan inverse of minus omega. So now find the value of omega at omega equal to 0 and omega equal to infinity. The essential points: at omega equal to 0, magnitude is infinity, 1 by omega, so 1 by 0 is infinity, so that's why magnitude is infinity. And also phase is minus 90, because if you substitute the value of omega as 0, this would be cancelling out, we would be left with only minus 90 degree. So at omega equal to infinity, magnitude is equal to 0, so 1 by infinity is 0, so that's why magnitude would be getting it as 0, and also 5, angle we would be getting it as minus 360 degree, because minus 90 minus tan inverse of minus infinity, so that's why tan inverse of minus infinity is minus 270 degree, so minus 90 minus 270 we would be getting it as minus 360 degree. Again separate real and imaginary part, try to separate it by taking the complex conjugate of this term. But if we see here we are getting stuck because we cannot separate here, because in the denominator side only we are having one complex term. Okay, so we can directly write it as no separation is possible. So we can say that we do not have any point of intersection in real axis as well as imaginary axis. It will be moving in a particular plane, so separation is not possible, and also there is no point of intersection, so there is no use of these two terms only. But in order to represent it in stepwise, we should be writing this. Okay, yeah, so we can now directly draw the Nyquist plot. Okay, so this is the Nyquist plot here. First thing here is the polar plot. The polar plot, how we should be drawing the polar plot is, how we should draw the polar plot is, at omega equal to 0, magnitude is infinity, so that's why, and also phi is 90 degree, so that's why from magnitude is infinity here, and the angle phi is minus 90 degrees, so that's why from here we should be drawing one polar plot. Okay, up to this point, and also at omega equal to infinity, magnitude is 0 and phi is minus 360 degree. So again we will be getting one same plot here. So this is the curve of polar plot here. Okay, and the mirror image of this here in the other side. So this is the curve of inverse polar plot. So this is for polar plot here. So this is for inverse polar plot. Okay, and here now this is for the first step, that is Nyquist contour. Here the range is magnitude equal to 0, phase is from minus 180 degree to plus 180 degree. Okay, that is from magnitude 0, phase is from minus 180, so it should be starting from minus 180. This is minus 180, it gets started from minus 180, and here you should be drawing one full circle up to plus 180 degree. Okay, again, so this is one full circle here, and also the outer part is magnitude, at magnitude is equal to infinity, you should be starting from plus 90, up to minus 90 at magnitude is equal to infinity, that is here it is plus 90. Okay, here it is minus 270, so here it is plus 90. So from here up to minus 90 we should be drawing the outer curve. Okay, and so this is the direction here. Okay, and this is the direction of the polar and inverse polar plot. So this is the simple Nyquist plot here. They have not asked to for determine the stability, so that's why. So hope you understood the concept of Nyquist plot thoroughly. So please do like, share and subscribe for our reports, because we have provided you all, since we have exam tomorrow. So that's why I've tried to provide you the Nyquist plot. So I hope that this video, it will be getting uploaded tomorrow. So that's why please do like, share, subscribe guys. Thank you.